In this video I'm going to show you how to create a comparator circuit. So that's one that uses an analog input like a light dependent resistor or a thermistor or a variable resistor. It doesn't have a set digital input. It's not either on or off, it's variable. So I'm going to show you how to do that. Off the useful circuits page you can copy and paste those circuits into Circuit Wizard. Now it won't work because it's pasted it as a picture, but what it allows you to do is it allows you to have it there and you can draw one up whilst that's there. So I'm going to start with my battery again. I'm going to work methodically from left to right, my 9-volt power supply. I'm then going to add in my resistors. I'm going to copy it again. I'm going to change its value. Now this here is a light dependent resistor, and that's a variable. Now I'm going to get rid of that variable resistor. I'm just going to use my light dependent resistor. I'm going to input those components and they're in sensors. You see they're both in there, variable and light dependent resistor. I'm going to get my light dependent resistor in. Then I need this component. Now that is an IC1, it tells me there, so I know where it's going to be. I know it's going to be in integrated circuits because that's what IC stands for. And there it is. That's an operational amplifier. Now that allows us to take a set amount of current and using a variable analog input allows us to amplify it so that we can power an output. So our output isn't either on or off, it's on or sleeping, and it's looking for the variable to be at a certain level. Now all I need to do is get my output, and I'll choose a flashing LED again, and link them all together. Now because I haven't got this bit here, all I'm going to do is I'm going to link that up to that resistor still. It's still going to be linked up to there, but this isn't going to exist. Do that a little too big, go back again, start again. This circuit can still be linked up to multiple outputs, like multiple resistors, but it can also be linked up to a 7-segment display, which I'll show you how to do after we've done this. Great. So now my circuit flashes. Now if I click on this, it gives me a sliding panel, and as that variable slides up, that switches off. See that? Slide down and it comes on. There, and it's off. Now it will stay on until that variable reaches a certain level. Now you can set that level, but that involves changing the value of this resistor. So have a play around with it and see what happens. Adding on multiple outputs is just the same as with your monostable circuit. Just add it in parallel. And you can have 2 flashing outputs. Now I'm going to add in my 7-segment display, and it's exactly the same as what I did earlier. Right, I'm going to take this part of my 7-segment display and I'm going to whack it onto the end of that circuit. Right, so I'm going to copy that in so that I can see what I'm doing. Delete that one now, I don't need it anymore. Paste that one in. And I'm just going to take this bit and stick it right on the end there. So I need my, where was it, my 400B. That one. I need that in about there. I need my 7-segment display in. There we go. I need to link all the legs up exactly the same as I did with the monostable. So what we're going to have here is a 7-segment display that's powered by a variable input. With the monostable it's either on or it's off. you've got your digital input, you've got your switch. It's switching it on or it's switching it off. Now that is still happening here, it is still being switched on and off, but it's not using a digital input, it's using an analog input, it's using something that's variable. Like this, there would be light levels, you could have a thermistor in there, so it could be heat levels. Right? So it's completely variable. Got to make sure I link all these up in the right way again, otherwise it ain't going to work. Don't forget this one out here, sometimes it always gets forgotten. Right, power it up and see. Got my 0 on there, get into my variable resistor, and as I slide it down and it triggers it, it counts. Now it can dip into there as much as it likes and it'll still count 1 until it goes back to there and switches the diodes off. Then when it comes back again, it counts 2. Let's have a look what's happening in the current levels there. We can see that it's the value of this resistor and that that's triggering our current to go along there and just into there, powering that. So that's how to use a comparator circuit if you've got an analog input, so something that's variable, with outputs and a decade counter 7-segment display.